maintain control over all your inputs. So this is a list of the new CWEs we needed for the level of abstraction we chose. For example, CWE 798, the use of hard-coded credentials. Right? For example, there are things that ship with hard-coded passwords in the firmware, backdoors. Other things that are hard-coded credentials, keys for DVD players. Those are hard to change. Pardon me?
Routers.
Routers, yes. And so forth. To rank the issues, we use importance instead of severity. Because last year we were concerned about severity. So by using importance instead of severity, we don't have to be limited to CWEs that will cause huge damage immediately. So we can include something that gives information, valuable information to hackers. So when there's an error message, there are many systems that will give you detailed information about the tables used in the database, which script was running, maybe even which user ID it was running as. And all those things can be very helpful for an attacker. We also did formal voting and scoring. Because last year what we had was a kind of sponsorship. People said, I believe this sort of CWE is very important. It should be included in the list. So that was subjective, depending on how convincing someone could be. But in 2010, we used two criteria, importance and prevalence, and we gave them score. And then after we have these two ratings, how do we sort the entries? So we have importance and prevalence. You could take the square of each and add them, or you could multiply one by some scaling factor. But risk is defined as the potential loss multiplied by the probability of occurrence. So it makes it a natural fit that you'd think of ranking the entries in the CWE by importance multiplied by prevalence. There were some issues in the ratings. So think about this CWE here. Download of code without integrity check. So if you're going to run code on your system, you want to make sure that nobody stepped in during the transfer and substituted or inserted their code in the middle, right? So if you're doing an update of your operating system, the download of the new code is all encrypted, or should be. The modern operating systems now all have encrypted downloads. However, think of JavaScript. It's all over the place. In Facebook, it's very difficult now to access a website with JavaScript turned off. So you download JavaScript, which is code that is going to run on your machine in your browser, but most people aren't concerned about trying to encrypt it. So one reason for that could be that it's executing in a restricted environment, right? So the risk is lower. So for this CWE, depending on the context you choose, whether you're thinking about JavaScript or critical updates, the ratings are different. Now with prevalence has problems too, because we only know about what's been found. On top of that, people researching vulnerabilities research what they feel like. So they can be capricious. They can want to report on hot things and not do it systematically. That leads to peaks in prevalence during certain years, and then the next year there's nothing, and then the next year then there's again some more vulnerabilities found of the same type. Then there's limited manpower to process discovered issues, to look everywhere for all sorts of information, everywhere in the world about someone finding a vulnerability. So some don't make it into the list of known vulnerabilities. And then the best ones are kept secret. We don't even know about them. They're sold on a market. They can be sold to government agencies. They can be sold to companies. There are companies offering bounties for that. We had a speaker earlier at the security seminar who was describing how they purchased vulnerability information from researchers. So we don't know about all of these. So to find prevalence, we used these sources. We used the Common Vulnerability and Exposures Enumeration, which is another effort by MITRE. We used also data from security vendors. And we also used personal experience and judgment, which is a little bit more subjective, but when there is no hard data on the prevalence of some weaknesses, that's what we had to use. Now, that sounded like a great idea, but when we tried to do it, we realized there were other problems with that. The CVE entries are not classified by CWE. Vendors, if they use the CWE, they use different levels of abstraction. So if a vendor reports on a very high level kind of weakness, and we're trying to separate the issues at the lower level, we're not sure to which one of those the data applies. So this year we had some uncertainties and variability because of that, and that's something to improve for next year. There were other ideas being discussed. People want to give more weight to, more importance to weight, more weight to importance or prevalence. They wanted to change the scale, right, the numerical values for each of the categories. So that led to interesting discussions. All right, so the top 25 list starts with guidance for different kinds of users. They say if you're a programmer new to security, you could do this, look at this first, and try to learn about this. If you're experienced in security, you can use a different ranking of the weaknesses. If you're a project manager, you can use this table and you can use this section and so forth. So for software testers, software customers, and educators, there's different guidance. So really, it's not just a list. There are several different sections in it and figures. Also new, we have mitigations. For example, I mentioned earlier the inputs. Same thing for the outputs. You want to stay in control over those. You want to lock down your environment. You should assume that external components can be subverted, and that your code can be read by anyone. And you should use industry-accepted security features instead of inventing your own, because they're tricky to get all right. So if you try to do them yourselves, there's a great risk that you'll miss one little detail. And then at the end of that, there's a mitigation matrix, which shows if you want to defend against this kind or that kind of weakness, then you can use this mitigation, and that's going to be highly effective or will have just a limited effectiveness. We also have general practices in the list. For example, you should use libraries and frameworks that make it easier to avoid introducing weaknesses. You should integrate security into the entire software development lifecycle, because it's more expensive if you do it at the end. It's more difficult. A lot of people give up, right? They develop a software product and then they say, you know, what if there are vulnerabilities in what we've done? Then they bring in a consultant and then you start getting a list of all that's wrong with the software. The cost of fixing that at the end is much, much greater than if you were doing it from the beginning. And chances are you're not going to be able to fix everything. Also, you should use a broad mix of methods to comprehensively find and prevent weaknesses. Code scanning is one example. Code reviews is another. So this is the list we ended up with. Number 1, cross-site scripting vulnerabilities. Now, I was debating if I should have started, when, like they do in shows, start with number 25 and build the suspense up to number 1. But I'll present them to you in the order they are. So, cross-site scripting, it's a weakness in web applications. SQL injection, when attackers can add extra commands when commands are sent to a database. Classic buffer overflow, that's more specific than what we had last year. Cross-site request forgery, I mentioned it earlier, that's also a web flaw. Improper access control. Untrusted inputs in a security decision, right? An example of that is when people store privilege information in a cookie. And when they retrieve the cookie for the web application from the browser, they trust the values in it. For example, administrator equals yes. Okay? So that's an untrusted input used in a security decision. We'll grant you all administrative privileges if you change no to yes. Path traversal. Right? If you're doing FTP, you're trying to download something and you try to have access to other files in the operating system. Unrestricted upload of dangerous file types. Let's say you have a website encoded in PHP and you're allowed to upload PHP scripts. Maybe then you can't get them to be executed. OS command injection. That can happen a lot when you have complex systems that are built with different computers and you want to send command to another server and you use SSH to do it over there, and then you compose a command, and inside the command you do string concatenation, right? And you use an input inside, and this input was not validated. So someone can add additional commands inside what you wanted to send to that server. Missing encryption of sensitive data. We talked about that earlier. Use of hard-coded credentials. We also talked about that. Buffer access with incorrect length value. That's a new one. PHP file inclusion. That's when you have a web application and the path for the inclusion of the PHP files can be changed by an attacker. And the attacker can specify a remote site, because PHP is so powerful and helpful that if you specify a URL instead